So let's wrap it all up. Today, we are looking at final thoughts on where AI is headed. And I want you to imagine something for a second. Imagine an employee who finishes this massive, complex coding project, right?
Okay.
And they realize they made a fundamental logic error on like page 4. So they instantly rewrite their own brain so they never make that mistake again. And then they just go right back to work. And they do all of this in the span of, well, about 3 seconds.
Yeah, I mean, it sounds like a pitch for a dystopian sci-fi
It
movie.
really does, but it's not. I mean, it isn't science fiction at all. That exact scenario is happening right now, like in real laboratories with real code. And for you, the listener, that is exactly what we are unpacking today. We've
Yeah.
got this huge stack of sources, research papers, CTO magazine articles, some Wikipedia histories, and these deep guides on agentic AI. And our mission for this deep dive is to just cut through the hype, cut through the panic about robots taking over, and look at the core reality.
And that reality is, well, it's that we are standing on the edge of a massive paradigm shift.
Mhm.
It's a shift that forces us to completely reframe how we view these tools.
Yeah.
Because for a long time, the public conversation has been trapped between two extremes, right? It was
Uh-huh.
either the Terminator coming to destroy humanity,
Mhm.
or it was this slightly malfunctioning smart speaker that couldn't even set a cooking timer without, like, accidentally ordering you a bulk package of paper towels.
Which is such a frustrating place to be if you're trying to actually understand the technology.
Uh-huh.
You're either paralyzed by fear or you're just rolling your eyes at how dumb the machine is.
Exactly.
So today, we are tossing out the Hollywood scripts. We're tossing out the smart home glitches. We're exploring the real future of AI, which is the leap into continuous learning, the really urgent scramble for ethical guardrails, and ultimately this reality of a human plus AI future.
Right. And that framework is crucial because the underlying data, the actual trajectory of the tech, it points to a completely different conclusion than the popular narrative.
Yes.
AI isn't actually replacing us. It's redefining what's possible.
Yes.
But to understand where it's going, we first have to understand how it's breaking out of its little chat box.
Right, because I think a lot of people still interact with AI like it's a hyper-intelligent search engine. You type a prompt, you hit enter, it gives you a paragraph of text, and then it just sits there, frozen, waiting for you to tell it what to do next. It's a very static relationship.
Right, and that is the traditional large language model experience.
Mm.
The human is the engine driving every single interaction.
Hmm.
But what we are witnessing now is this shift into agentic AI,
Okay.
specifically what developers are calling the level 3 collaborative agent phase. This is where the AI operates within a closed perception action loop.
A perception action loop. Okay, let's unpack this, because that implies the AI is somehow looking at the real world and making choices on its own.
It does, yeah. Instead of just waiting for a human prompt, an agentic AI is given a high-level goal. And to achieve that goal, it can autonomously browse the web. It can call external APIs.
Which, if you aren't familiar, calling an API is basically like giving the AI a digital menu to order services from other software, like telling a web scraper to go fetch data.
Exactly, or telling a payment gateway to process a fee. The AI takes an action, it perceives the result of that action, evaluates if it moved closer to the goal, and if it made a mistake, it actually alters its plan and tries again.
It's like we've upgraded from a really fast encyclopedia that waits for you to ask a question to an eager junior analyst.
Mhm.
You say, get me a market report. They go out, do the research, realize the data they pulled from one site is outdated, so they correct their own mistake,
Right.
pull fresh data, and compile the whole thing before finally walking into your office with the finished report.
What's fascinating here is that dynamic, ongoing process. The AI transforms from a one-off tool into a continuous learner. And the mechanisms behind this continuous learning are, well, they're staggering. Take a system from the sources called Sika.
Oh, Sika, self-improving coding agent. This was the example I was teasing at the very beginning, and the mechanics of it just blew my mind.
It is a remarkable piece of engineering. Stika doesn't just write software for a human user. It modifies its own underlying source code.
Wow.
It acts as its own software engineer. It looks at an archive of its past performance on coding benchmarks, diagnoses exactly where its logic failed, proposes a structural improvement to its own architecture, implements the change, and then runs tests on itself to verify it.
It's basically doing open brain surgery on itself to get smarter, entirely autonomous.
A visceral way to put it, but functionally accurate. It's this iterative cycle of self-modification. And then you have initiatives like Google's AlphaVolve, which takes this autonomous optimization even further. It combines LLMs with evolutionary algorithms to discover entirely new algorithms.
Wait, meaning it's inventing new ways to do math?
Precisely. It has autonomously discovered new, highly efficient algorithms for complex operations like matrix multiplication,
Right.
which is essentially the bedrock math that makes modern computer graphics and AI neural networks function.
Right.
Finding a faster way to do it is like finding a secret tunnel in a maze that thousands of human mathematicians have been trying to solve for decades. It's also optimizing Verilog code, which is the actual hardware description language used to design the physical computer chips.
Okay, I have to stop you there. Because if an AI is writing its own brain architecture, discovering entirely new math shortcuts, and optimizing the physical hardware it runs on, how are we not dealing with a superintelligence? Like, if Sika is rewriting its own code, it must fully understand what that code means, right?
That is the exact trap our human intuition falls into.
Hmm.
Because it looks so incredibly competent, we assume comprehension. But the reality is much stranger and, frankly, a bit more alarming. It all comes down to a concept known as the stochastic parrot.
The stochastic parrot? I love the visual of that. But tell me why it means the AI isn't actually a genius.
Well, stochastic essentially means probabilistic, or determined by a random distribution of probabilities. No matter how eloquent an AI sounds or how flawlessly it writes a block of Python code, it is fundamentally a statistical pattern matcher. It is predicting the next most likely word or the next most likely line of syntax based on the billions of examples it ingested during its training. It does not possess true semantic understanding.
Okay.
It has no internal concept of what the code actually does in the real world.
So it's like someone who has memorized a Spanish dictionary and can perfectly recite phrases, but has absolutely no idea what the words actually mean. They couldn't order a coffee.
That's a great way to think about it. The sources bring up this classic example to demonstrate the limitation. Imagine you train an AI, let's call our parrot Polly, on a massive data set where the specific phrase Paris is the capital of France appears tens of thousands of times. If you prompt Polly with Paris is the capital of, it will instantly and confidently say France.
Because statistically, France is the most probable word to follow that sequence.
Exactly. But if you ask Polly the inverse question, France is the country where what city is the capital? And Polly hasn't seen that specific grammatical structure enough times in its training data, it might completely fail.
Really?
Yeah, it might hallucinate a random city or just spit out nonsense because Polly doesn't actually understand the concept of Paris or France or a capital city. It just knows the math of the words.
Wait, if they're just stochastic parrots spitting out high-probability word salads, how can we trust them to act autonomously as agents? We just talked about them browsing the web and using APIs.
You've just identified the greatest vulnerability of modern AI. That exact lack of true comprehension makes blind deployment incredibly dangerous for businesses.
Yeah.
An AI can generate a plan of action that seems incredibly fluent on paper, and yet is completely nonsensical or actively harmful in reality.
Like, give me a scenario of how that goes wrong.
Let's say a business deploys an agentic AI to manage its server storage. The AI detects a redundant storage error. Based on probabilistic pattern matching, it determines that the most efficient, highest probability way to resolve the redundancy is simply to format the drive.
Oh, no.
Right. It confidently wipes the company's entire database, entirely unaware of the catastrophic real-world consequence. It solved the puzzle perfectly, but destroyed the business.
So because these highly capable agents lack a human understanding of meaning and consequence, we obviously cannot just unleash them. We have to somehow program a moral compass into the system itself.
Yes, and that realization is driving this massive pivot toward ethics by design. Because we are delegating actual responsibilities to these machines, we have to entirely rethink what responsibility even means. The philosopher Daniel Dennett has proposed a functionalist approach to AI ethics here.
Okay, let's explore Dennett's approach, because usually when humans talk about responsibility, we are talking about guilt, Like, did you mean to do it? Did you have free will?
Right, but you can't put a piece of software in jail, and an AI can't feel guilty. Dennett argues that responsibility isn't about an individual internal emotional state. Instead, it's a shared functional role across the whole socio-technical ecosystem.
The socio-technical ecosystem, meaning the creators, the users, and the AI itself.
Exactly. Responsibility is distributed across that entire web.
So what does this all mean for us? If an autonomous car crashes or an AI wipes that company's database, like you said, who is actually to blame in this distributed web?
Dennett's point is that delegating to AI doesn't absolve humans. Instead, humans shift from being the direct decision makers to the architects and overseers of these ethical guardrails.
Okay, but how do you architect a guardrail for a probabilistic parrot?
One of the most promising frameworks from the sources comes from Basti and Vitello. They propose implementing a transparent logic system built directly into the AI. They call it a deontic higher-order logic ethical reasoner.
Deontic higher or wow. Okay, that is a heavy piece of jargon.
It is incredibly dense, I know, but the mechanism is elegant. Think of it as an automated mathematical checkpoint. Before the AI agent is allowed to take any physical action, this internal reasoner forces the AI to evaluate its own proposed decision against a strict, hard-coded set of ethical rules.
Oh, so it transparently checks itself before acting.
Yes, it separates the probabilistic generation of ideas from the execution. The AI can suggest wiping the database, but the reasoner steps in and says, does this violate our rule against data destruction? Yes. Execution denied.
But creating that rule book brings up this inherent issue of bias, right? Like whoever writes the rules or whatever data the AI is trained on dictates what is good. The sources actually mention this with the ChatGPT and the trolley problem.
They do. And the results of those trolley problem variations were very revealing. The data showed that the AI's outputs consistently demonstrated a pro-environment and left-wing liberal ideology in its ethical calculations.
And I want to be super clear here for the listener. We are strictly impartial on this. We aren't bringing this up to validate or condemn any political stance. We are purely using this as factual evidence from the text to illustrate that AI outputs reflect their training data.
Absolutely. The AI isn't deciding to be political. It's a mirror. It reflects the data it ingested, which contains human biases and ideologies. If an AI is making autonomous decisions based on statistical patterns, and those patterns lean heavily in one direction, its real-world actions will inherit that bias.
Which makes it completely clear why we need that oversight. We can't just assume it'll be fair. And this shift in human responsibility from doing the manual work to overseeing the ethical framework, it perfectly illustrates the ultimate destination here, the human plus AI future.
Right. It's an integration. And to make that integration work safely, enterprise systems are adopting two primary governance models, human in the loop and human on the loop.
Let's break those down. Human in the loop prioritizes control and risk mitigation, right? Like a loan officer.
Yes. The AI compiles a massive risk profile for a corporate loan in 3 seconds, but a human must actively review it and manually click Approve. The human is a mandatory toll booth.
Got it. And human on the loop.
That prioritizes speed and scalability. The AI executes tasks autonomously from start to finish. The human acts as a strategic supervisor. You watch the dashboard, and you only intervene if the system flags an anomaly.
So you manage the system while the AI manages the tasks.
Exactly.
And this changes daily workflows entirely. The texts introduce this concept called vibe coding.
Yes, vibe coding.
I love that phrase, where a developer gives high-level conversational prompts like, make this landing page modern, and the AI just executes all the detailed syntax.
This perfectly captures the shift.
Here's where it gets really interesting for you, the listener. You aren't competing against the machine. You're becoming a film director. You set the vision, the vibe, and the AI is your camera crew, lighting team, and editor making it happen.
And if we connect this to the bigger picture, you realize AI acts as a force multiplier. We are moving from human versus machine to a collaborative ecosystem. Humans lead orchestration, AI handles execution. And this isn't just in software, it's expanding into everyday life.
Right, like AI in smart homes. Project Astra.
Yes, multimodal understanding. It sees and hears the physical environment.
So instead of asking for the weather, your home AI sees you grabbing an umbrella, cross-references the live radar, and proactively tells you the rain is stopping so you don't need it.
It becomes a deeply personalized partner. And the applications for senior care are profound. We are moving toward emotional AI and predictive analytics.
Right.
By analyzing multimodal data like a slight hesitation in a physical gait, the AI can anticipate a health risk days before it's an emergency.
Oh, wow. So it notices a parent dragging their foot and proactively alerts a doctor.
Or adjust the environment to stimulate cognitive function. It's a partner that never sleeps.
This whole journey, I mean, we started talking about stochastic parrots, these probabilistic machines that don't really understand anything. But through continuous learning and shared ethical responsibility, we really are entering this human plus AI future.
We are.
So to wrap up this deep dive, the core explanation is clear. AI isn't replacing you, it's redefining what's possible for you.
Exactly. But I'll leave you with a final thought to mull over.
Mm.
As AI agents become fully integrated into our lives, managing our homes, writing our code, and executing microethical decisions on our behalf, will human intelligence eventually be measured not by what we know or how fast we work, but strictly by the values we choose to enforce?
That is a phenomenal question to end on. Thank you so much for taking this deep dive with us.